So again, so I really want to strongly encourage you to learn these ideas. We will discuss in the class, and you should. The more you read and learn, you will be more. You become more confident. You know how to read. You know how to stand up on your own feet, and that's what we would like to facilitate. All right. So not that. So please don't think you should not be asking me questions, but I encourage you to ask questions. But I want you to do self study also. All right. Okay. Good. So now let's see here. Okay, this is the code, and yeah, we would like to take this code. What version? Shorter version. Well, not exactly Sriharsha, but in some cases it will work, not in every case. In some cases, we can replace an if statement with a ternary operator, but not in all cases. So Anjali, did you get to take a look at this code in the last class? Because we looked at this init underscore flag so much. Did you get to take a look at this code? No, I want to ask you because we discussed about this init underscore flag quite at length in the last class and you are asking the same questions. I would like to know, did you get a chance to look at this code later? So I want you to know, just don't, you have to do a lot of preparation for the class. Those of you who are, kind of bit lagging. So watch the lecture again. And I don't want to share the code because I want you to watch the code and type the code by yourself. Otherwise, you don't get it. So you should take a look at the code, think about the logic, how it is flowing. And this is not at all hard logic. This is a baseline logic. And if you have trouble with this, then going down the lane when we try to solve more complex problems, it will be harder for you. So someone raises their hands. I would like you to ask the question on the chat box. That will be easy. So I have to tell you, so no, little bit honest with you and tell you that I don't know how much hard work you are putting in. The questions that you are asking, they are basic questions, and so you should put in effort in reading the textbook, watching the video lecture, and then what the other things that I would like you to do is, as you watch the lecture again, type in the code, run the code. So and then you try to solve the related easy homework problems at the back of your textbook, which are given as homeworks. So all these things you should do, and you cannot expect no everything will be kind of made so easy for you, and the core ideas, the important ideas are already being discussed. So there is in GDB, when we use printf, there will be a problem. I will explain the problem later. But just go ahead and do the next. So when it hits a scanf or then you will get the whatever that you print, it will be printed. And sometimes when the screen gets messed up, use Control L keystroke to clear up the screen. Okay, I think let's get started. Let's So now you have entered into universities, so you should all know be in self-reliant mode, and we will facilitate that. In the class, we will facilitate that. So let's get started with this question. So Nikhil has this question: when do we use left flower bracket and right flower? No, these flower brackets. It's very simple. Can someone answer this question? Yeah, it's a block statement. So what happens is in the if statement, if condition. So the syntax for this if statement, if we go here, let's look at this document. Yeah. So if you see this document, so the syntax for if statement is if expression. So there is a kind of interesting. There is an interesting simple way to do it actually. So if expression, and so you have a statement one, else statement two. And these statements, they can be what are called as a simple statement or a block statement. So an easier way to explain is, let's go back here to the code we are looking at. So in this code, like for example, on line 19, in the else part of this if statement, we have only one statement. So we can just get away with we don't need a left and right flower bracket. We don't need a left and right flower bracket. Are you with me here, Nikhil? But on the contrary, if I remove this the flower bracket on line in the if part, it's going to be a problem, because the way the compiler treats this is if init flag is equal to true, then max is equal to current underscore number. That is how it treats it. So when there are multiple parts in the if, okay, like for example, here in the if part, when we have multiple parts, then we put all those multiple statements in one in left and right flower brackets, and we call this as a block statement. Are you fine, Nikhil? Does this answer you? This is an important thing. It's very fundamental. Good. So now let's try to convert this code into a while loop. Yeah. So let's try to convert this code into while loop. So Control A, Control C. What other questions do you have? So someone said, so with respect to, did you all understand in how we converted this code into a while loop? Those of you who watched the video lecture. How does the while loop work? While some condition is true, so let's quickly convert this. So while some condition is true, so while some condition is true, you want to do some stuff. So here, what should be the condition on line 9? So the condition we can use on line 9 is either equal to 1, or it's not equal to end of file. Both will work. So as we keep reading, so what we are saying is you keep reading the input, and if you don't hit the end of file, you keep continuing. As long as you don't hit the end of file, you keep continuing. And then what do we do? So, and then we have this code here. Yeah, so we should not enter a character with this. By mistake, if you enter a character, you get into trouble in this approach. Yeah, it's true. So equal to 1 is a better thing to do. So that by mistake, if you enter a character, then also you'll have a problem. Anyway, so this is because you cannot flush that A out from the input buffer, and yeah, you'll get into trouble there also. Anyways, so let's focus on this here. So you enter the while loop, and no, so if init flag is equal to 1, that is you entered the while loop for the first time. When you enter the while loop for the first time, that is when you read the first input for the first time, the init flag will be equal to 1. Anjali, pay attention. So when you enter the loop, while loop for the first time, you read the first input and the init flag is equal to 1. So your current estimate of max is equal to whatever the number you have read, and you make init underscore flag equal to 0. And then you go back to the beginning of the while loop, you read the next number, and when you check the init flag, it will not be equal to 0 because it's not the first number. So you go to the else part. So you compare the current number with the estimate of the max, and if the current number is greater than the max, you say max is equal to the current number. And finally, from line 22, so let's say once you reach the end of the sequence, that is you get the end of file symbol. So what happens is you come out of the while loop, you check if the init flag is equal to 1. When will be the init flag equal to 1? You didn't enter the while loop E1 once, in which case you will say that the sequence is empty. Otherwise, you print the maximum. So this is the plan. Does it make sense for you, all of you guys? Is it okay? Are you all with me? Happy? Anyone unhappy with the code that we have? Anything bothering you? Okay, good. So now we have, now we will look at another example code. This is the sum of first I numbers, control A, control C. So what is the idea here? So before we enter the loop, so these are the things that I would like you to understand. So, so before we enter the loop, this is what we would like to initialize. Yes or no? This is the initialization statement. And the loop goes from line 12 to line 19. And before you enter the loop, you want to check this condition. If this condition is true, then if this condition, if I is greater than n, then you go to the end. Otherwise, you continue in the loop and then you execute. This is the body of the loop. So actually line 16 is the body of the loop. Okay, let's go. Yeah, let's try to rewrite this code so that it becomes easy for you to understand. So let's have this code below as it is, and we will try to write the code above. So here. Okay. So what do we do? So we want a for loop. So there are three parts in the for loop. There are three parts in the for loop, and the for loop has a body. So before we enter the for loop, so here in this place, uh, we would like to have set up everything so that by the time we enter the for loop, we have kind of everything is nicely set up for us. So what do we want before we enter this for loop? We want, number one, the variable I should be equal to 1. Number two, the sum variable should be equal to 0. These are the two things that we would like to have in this loop. And before we enter the loop, what we would like to do is we would like to check if I is less than or equal to n. I is less than or equal to n. If I is less than n, then what we do is sum is equal to sum plus I. This is what we do. And after we are done with the executing the body of the loop, we want to do at the end of the loop, you want to, this is what we would like to do. I is equal to I plus 1 is what we would like to do. But what, so, uh, but then this last statement which you would like to execute at the end of the loop, usually we can write it in the third place here, the third placeholder. So that way it becomes very clear. If someone is looking at your program, it becomes very easy for them to understand what you are trying to do. By the time you enter the loop, when you are about to enter the loop, you want the variable I is equal to 1 and sum is equal to 0. Before you enter the loop, you check if I is less than or equal to n. If that is the case, you enter the body of the loop. At the end of executing the body of the loop, you execute the statement I is equal to I plus 1. And then after that, what you do is again you evaluate this Boolean condition. If it is true, you continue again execute the body of the loop. This is how we do. And if you want to write equivalent while loop to this, if you want to write equivalent while loop for this, like for example here, so what should we do before, if you want to write while loop, before you enter the while loop, so we should say I is equal to 1, sum is equal to 0, and we will say, so while the condition I less than or equal to n is equal to true, you want to execute the body of the loop, sum is equal to sum plus I, and then you want to say I is equal to I plus 1. So the while loop that you are seeing on line number 17 to 22 is equivalent to the for loop that we have from line 13 to 15. No, so Nikhil, it's okay. So you can, if you want to put sum is equal to sum plus I on the action part, that is also fine. But it's not like it is a kind of, what do I say, some convention. There's no strict semantics. But whoever is doing, they understand. So the first thing I want you to understand is, do you see that the for loop and line 17 to 22 are the equivalent to each other? How many of you see that? That the for loop from line 13 to 15 and line 17 to 22, the code is equivalent to each other. So it's an important idea. So these two are equivalent to each other. Okay. Anyone having trouble here? I'm just commenting this code. Anyone having trouble here? So if you look at this for loop, there are different variants of this for loop. Like for example, another way of writing this for loop is, you can say I is equal to 1 here, sum is equal to 0 here, and not have anything here. This is also fine. Why will sum be equal to 0 every time? The line number 13 to 15 is equivalent to line number 17 to 21. No, it's okay. It will come with experience. Sometimes for is good, sometimes while is good. For the time being, you don't worry about it. Okay. Good question, Srijan, but it will come with experience. Okay. Yeah, in this case, semicolon is line 17 to, no, this is another version. Are you with me on this, that line 17 to 23, it's the same? That semicolon is necessary. That is the syntax rules. Semicolon is necessary on line 20. Yeah, it's important. And actually, so this is, so you can even have like this. You can have even this I is equal to I plus 1, not here, and have it here. This is also permitted. Are you with me on this one? Line number 26 to 31. Are you all with me on line number 26 to 31? Does it make sense? We can have one more thing also actually here. I is equal to I plus 1 comma sum is equal to sum plus I. Even this is also allowed and have nothing in the code. Does this make sense? Line 35 to 37. Are you all with me? And if you are not happy with this version, so what I want to say is there are different versions of the code. What is the smallest code you can write? Line number 41, is it the same? Are you with me on line number 41 where we have one line for statement? Line number 41. That's all. So there are different ways of writing it. And is there any way by which we can get away with I less than or equal to n here? We are playing with, if you see this whole thing, we are playing with what is present here and what is present here in the for loop. So you have these things, three things, right? So here we are able to move, the this and this we are playing a lot, like these things we can move up here, and some statements which are here you can move up here. All those things are possible, but this one is critical. You cannot move this inside the for loop or outside the for loop. You cannot take it out. This is not possible, and you cannot take it in. This is not possible. Are you with me on this one? Moving this and this, this the first and third parts, they are kind of, you move things around, but the condition it's not. But what we have here, it is. What do you mean by prefix or postfix, Abhinav? I don't get it. Yeah, so here it depends. It doesn't matter. It depends. It depends on the program. But in the particular example that we are working with, it's not going to matter. All right. Did we take a look at the prime number program before? Just wanted to check with you guys. Did we look at the prime number program? No. Okay, in the video you have seen. Okay, now let's try to write the prime number program. So let's say prime. Now it will be an infinite loop. If you don't keep anything in the condition part of the for, it will be an infinite. No syntax error. Okay. So now let's see. So now we'll say printf enter n. All right. So how do we write the loop here? So let's say we want to write the main code for main logic. You will hear main logic begins here, main logic ends here, and then so we want to write code here. Okay. So what we can do is we want to check for int I is equal to 2. We want to check if I less than or equal to n minus 1 plus I. So we are checking all the lines from so if you are checking, what we want to do is we want to check if n is divisible by 2, if it is n is divisible by 3, if n is divisible by 4, so on and so forth. So we will check if n percent 2, if it, sorry, not percent 2. So what will the percent operator give? It gives a reminder. So we check if n percent I is equal to 0. If n percent I is equal to 0, what does it indicate? What does it indicate? That I is a factor of n, so and n is a not prime. So what do? Is we say prime is equal to false. And then we do what is called as a break. We break, when we use a break statement, what happens is we come out of the outermost, the innermost for loop enclosing the break statement. The innermost for loop enclosing the break statement is on line 11. So we break from this loop and we come out of this loop. And so I want to introduce a new data type for you, include std bool.h. So bool prime, we use, so initially we assume that the number is a prime number until we prove it's a composite number. So until we start with the assumption that a given number is prime, until we prove it's a composite number. How do we prove it's a composite number? By when we find a factor for it, we prove it's a composite number. That's what we are doing on line number 14. And then we break. And then what do? We check if prime. Yeah, if it's prime, then what do? We print printf %d is prime /n else. Yeah, it's case dependent. Are you with me in the program logic? And then maybe we can say, so if n is equal to 1, we kind of say printf. We can say percent 1 is this true? 1 is neither prime nor composite. And then we exit from the program. Exit just like printf and scanf, exit is also a function call, and that 0 is what is called as a return code. For the time being, don't worry about it. You just return some 0 or 1. It doesn't matter. Are you all with me on this program? Does this make sense? Can this problem be done without using stdbull.h? You tell me, Shreya, is it possible to solve this problem without using exit? We exit the program, that's all. And don't worry about the zero that we are passing here, don't worry about it. But exit, essentially, the program gets terminated. No, we cannot use break instead of exit. Break doesn't work. Break doesn't work. Break finds the outermost for loop, and then we come out of that for loop. What if we input 2 here? If we input 2 here, what happens? Yeah, check what if you input 2, what will happen? Tell me what happens if we input 2. Will we enter the for loop? We cannot enter the for loop because I is equal to 2, I less than or equal to 1. So 2 is less than or equal to 1 false. You don't enter the for loop. So the prime flag will be equal to true. So you print it is. So GCC prime for.c. Yeah, exit is present in stdlib.h. This is one, other is this void. So if I enter 1, it says 1 is neither prime nor. Exit returns from the program. So we will understand a clear difference between return and exit in the next class when I introduce functions. We can use goto. So I use it just goto to kind of see how control flow works. But usually speaking, you should never try to use goto in your program. Okay, so you can do that. It's not a good because goto makes the program less structured. Like for example, if you see the code here, so I have the prime. Let's look at this sum program versus here. See, like if you look at this code, you have to see, where is this end present, where is this loop present. Tracing the code is very painful, but if you go look at this loop, it's just there in one line. So it's easy for you. So for program readability purpose, we should not we use goto unless there is no other option for you. See, we want to terminate the program as soon as we see n is equal to 1. We want to print a message and we want to exit the program. That's all. So that's the reason behind the code for line 13 to 16. What if you want to wait till root n? So you just use, you should try to find the square root of n. I don't know how you can, yeah, so it's a good problem. Are you all with me on the for loop, if statements, exit? Doing all right? Happy? What is your state? If anyone is feeling a bit overwhelmed, you can drop me a private message. We'll see how I can help you. Good. If you just use bool prime, it will. Yeah, let's try to execute it in GDB. Otherwise, why do you think it will give an error? We have included std bool.h, so we will. Let's try to execute it in GDB. gcc minus g prime for.c gdb a.out. Yes. So now I executed line number 10, but enter n is still not printed on the screen. There is a reason for it. So when you're doing GDB, don't get, don't worry about it. You just go ahead. No, why will it give an error? Otherwise, I don't understand what you're saying. We can have variables which are not initialized, na? Yeah, we can have variables which are not initialized. Yeah, so B main is short form for break main. Yeah. So and then when we do next, you get now after it hits the scanf, printf gets printed on the screen. The whatever the printf is trying to print, it gets printed on the screen. Let's say I enter 1 here. So 1. So now I am doing Control L because my screen is a bit messed up. And on line 13, where will we go on line 13? What is the value of n? Print n is 1. Okay, so now we do next. So since n is equal to 1, you enter the if statement. And then when we do next, what happens is it got printed. 1 is neither prime nor composite got printed. So whenever, so usually what happens is when you do printf, okay, so this I will take it up in a different class. When you do printf, printf stays in what is called the message that is being printed. It stays in what is called as an output buffer. Can you all mute, guys? There is no command to go backward. So Rahul has this question. I'll just explain this. Maybe in a different class, I'll give a detailed explanation. So when you do printf, what happens is the message that you are printing, it goes to what is called as an output buffer. Pay attention, guys. This is a new idea, bit tricky to understand. This goes to output buffer, and the output buffer gets flushed onto the screen under 3 conditions. Number 1, buffer is full. If the buffer is full, it gets flushed. Number 2, there is /n encountered /n in the encountered /n. Third is scanf function got called. So here when on line 14 when we did a printf, there is a /n there. Because of that, the output buffer got flushed onto the screen immediately. Did you understand, Rahul? But on line 10, when GDB executed printf, there is no /n there, so it didn't get printed on the screen. But when it hits scanf, But when it hit scanf, it got printed. That's true. As soon as it you keep doing printfs, at some point the buffer gets full. Yeah. So here it got printed at line 11 because of condition 3, and here it got printed because of condition 2, and condition 1. That's true. That's true. Yes, sir, Rahul. If you remove slash n on line 14, it will not be printed. So now if I do next, so I'm exiting from the program. So when we hit the exit function, we exit from the program. Are you all with me here? Do you understand what's going on? Is there anything else you would like to ask me regarding the loops? You will. In the next class, we'll start with functions, but if you're all good with this, you want to see condition. You try to write a program, Harshal, and see. There is no switch loop. It's a switch case statement. You need some practice. No, that's why homework problems are there. So you should go back to the back of the textbook and start working on them, Sumant. I want all of you to start working on the problems that are at the back of the textbook immediately. So Nikhil has this question. So in do while loop, so it's a, so what do we do? So we have something like a do while some condition. So here in this case, the body of the loop is guaranteed to execute at least once because we are checking the condition at the end. There are some problems where this makes sense. But right now I'm not, can someone think of an example where we have to, where the body of the loops needs to be executed at least once? Yeah, it depends on the context. Yeah, do while. Yeah, in the do while. Oh, to check the factors of a number. I need to input at least once. Anyway, so we will get some interesting examples later on. Are you all with me in today's lecture? So do you understood all the examples here? Okay. Okay, then I think that this is a good place to take a pause, and then in the next class we will